product to sum and sum to product formulas. Chapter 7, Section 7. Well, as that sounds, that means we're going to turn multiplication into addition, and we're going to turn addition into multiplication. So product to sum formulas, the sine of alpha times the sine of beta is equal to 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. And yes, I feel your pain. It seems like we took something that should have been relatively simple and turned it into something that is not so simple. Cosine of alpha cosine beta is equal to 1/2 cosine alpha minus beta plus cosine alpha plus beta. And then sine of alpha cosine beta. Notice the first two were staying in the same trig function, sine alpha sine beta, cosine alpha cosine beta. Now we're sine alpha times cosine of beta is equal to 1/2 sine alpha plus beta plus sine alpha minus beta. Again, these formulas are on the formula sheet. Feel free to use that formula sheet. I just can't keep track of all these unless I have something of that sort. I have to admit, one of the happiest days in my college career was when I had a calc teacher, actually a differential equations teacher, that said, well, in Calc 2, you went through and you proved all of these differential equations. So I'm not going to require you to do that again. Get yourself a set of tables. And that's where I went out and I got the CRC math tables and formulas book. And I've had that ever since then. So realize that part of what we do when going through this process of learning is we have to prove things and we have to go through and memorize things that otherwise, when we get into the real world, we can then use a reference table or use other methods to find it. But it's part of the process, and it may seem annoying, and many times it is annoying, but it's a matter of getting used to the methods and being able to recognize, hey, there is a formula for this. So whether you can memorize all these formulas for all these trig functions isn't as critical as recognizing, wait, that's cosine alpha times cosine beta. There's a formula for that. And then being able to go and use that formula. And that's where the biggest thing is. It's not that you necessarily have to remember the formulas and how to do it all, but being able to recognize, wait a second, there is a formula for that, so I can look that up, as opposed to just getting stuck there, not being able to do anything. Okay, so let's use the product to sum formulas. Express sine of 2 theta cosine 5 theta as a sum containing only sines or only cosines. So notice with this, the purpose here is we're changing it from having two trig functions that we're dealing with to dealing with only one trig function. Instead of dealing with sine and cosine, we're going to deal strictly with sines or strictly with cosines. So in this case, sine of alpha cosine beta is equal to 1/2 of sine of alpha plus beta plus the sine of alpha minus beta. Now notice here too, that if we're looking for exact values and such, again, we're using the sum or a difference to get that, which allows us to work with exact values, whereas alpha or beta may not have worked out so nicely for us because it may not have given us values that we needed. So we have sine of 2 theta cosine of 5 theta is equal to 1/2 sine of 2 theta plus 5 theta plus the sine of 2 theta minus 5 theta, which gives us 1/2 sine of 7 theta plus sine of negative 3 theta. And then there's one more step we can do. We can use our odd even function. We've got the sine of a negative angle. Well, the sine of negative 3 theta is equal to negative sine of 3 theta. So we can make that 1/2 sine of 7 theta minus sine of 3 theta. Well, let's go to sum to product formulas. So now we're going to start with the sum of two trigonometric functions and turn it into the product of two trigonometric functions. So sine of alpha plus sine of beta is equal to 2 times the sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Sine of alpha minus sine of beta is equal to 2 times the sine of alpha minus beta over 2 times the cosine of alpha plus beta over 2. Cosine alpha plus cosine beta is equal to 2 times cosine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. And the cosine of alpha minus the cosine of beta is equal to negative 2 sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. So again, just a bunch more formulas, not necessarily pretty. You may be able to pull things together saying, gee, you know, the sine functions, the sum and difference there stuck with sine cosine. Whereas cosine function, the plus and the minus, those went, the addition had cosine, cosine, subtraction had sine and sine. So maybe you pull that together. Maybe you notice that for the sine formulas, you had for addition, alpha plus beta and then alpha minus beta. For subtraction, you had alpha minus beta and then alpha plus beta. So maybe you pull that out of it. Whereas for the cosine functions, it was always alpha plus beta, alpha minus beta. Just trying to give you some thoughts of how you might remember these. Again, I don't. My mind does not remember formulas that well, and I do the best I can with them. And if possible, I use a formula sheet or I use a table so that I can just reference that. So let's use the sum to product formulas. Because remember, the most important thing isn't that you can memorize formulas. What's important is that you know how to utilize formulas. I would be a very rich man if I got a nickel or a dime every time a student misused a formula in one of my classes. So it's critical that you understand how to use formulas and how to implement them. Not as critical that you memorize them, because let's face it, you can look up formulas pretty much anywhere. Okay, so express the sine of theta over 2 minus the sine of 3 theta over 2 as a product of sines and or cosines. So that's saying we could have sine functions or cosine functions or both in there. Whereas with our previous example, we had to put it where it was strictly in terms of sine or strictly in terms of cosine. So this time we're not dealing with that. We can have sine or cosine or both. So that's the difference of sine. So sine of alpha minus the sine of beta is equal to 2 times the sine of alpha minus beta over 2 times the cosine of alpha plus beta over 2. So that's the sine of theta over 2 minus the sine of 3 theta over 2 is equal to 2 times the sine of alpha is theta over 2, so theta over 2 minus beta 3 theta over 2. So we have theta over 2 minus 3 theta over 2 times the cosine of theta over 2 plus 3 theta over 2 over 2, which we can now combine those. We've got theta over 2 minus 3 theta over 2. So common denominator, we've got theta over 2 plus 3 theta over 2, common denominator. So theta over 2 minus 3 theta over 2 gives us minus 2 theta over 2. So giving us 2 times the sine of negative 2 theta over 2. And theta over 2 plus 3 theta over 2 gives us 4 theta over 2. So times cosine of 4 theta over 2 over 2. Now we see here that we can do a little simplification. And be careful about where you do your division here and where you're canceling. You've got negative 2 theta over 2 over 2. When you cancel that 2 from the denominator, that is canceling from the numerator of the numerator. I hate to use that over and over again, but remember 2 is equal to 2 over 1. So we're not canceling out the denominators of the top of our function. We're actually canceling out the numerators. So that negative 2 theta over 2 divided by 2 cancels out to be negative theta over 2. And the same with cosine. That 4 theta over 2 divided by 2 gives us cosine of 2 theta over 2, which, as you can see, there's still another cancellation we can do. So we get negative 2 cosine theta over 2 cosine theta, because what we did was we took that 2 theta over 2 and we canceled, and we also used the odd and even properties to turn sine of negative theta over 2 into negative sine of theta over 2, leaving us a final result of negative 2 sine of theta over 2 cosine theta.